Several of my life's ambitions have been fulfilled at the moment. One is to get the title of a Pink Floyd song into a book not so long ago. The other has been to give a talk which involves a Monty Python quote. This is really what the talk is all about, but I really want to get onto the people's front of Judea. What did the Romans ever done for us? This is the faculty here, and here's the list of what have engineering maths ever done for us, and all that list is there. Brought peace, shut up, you know. Now, the faculty is lucky to have the only Nobel Prize winner in Bristol University who was an undergraduate, Paul Dirac. I don't know how many electrical engineers know that, but he is the very first engineering mathematician, if you like, and he should be more loud praised, in my view. Computer science was invented by a mathematician, Alan Turing, and how many people know who this is? You've got 2 seconds. Maxwell, James Maxwell, electrical engineering. So there's quite a lot of mathematics going on already in the faculty. Now, Dirac, Maxwell and Turing all use mathematics to solve important problems in the 19th and 20th centuries. Bristol has its own engineering maths department, which is ready to solve important problems in the 21st century. But what you should not do is just take our word for it. Here's a comment by Claire Gris, and she's currently head of UOB Life Sciences. And she wrote to me not so long ago saying that we were very supportive, patient, warm and instrumental, turned life sciences from somewhere that was way behind the curve to somewhere that's riding the crest of the wave. I didn't actually tell her what to write there. What we do not do is have solutions which look for problems, okay? We are not in that kind of league. So you don't come to us and say, well, you do this, can you help? It's much more of the give us the problem and we'll get involved. We're similarly not of this type of mathematician, Hardy, who said, I've never done anything useful in my life, no discovery of mine will make the least difference to the world. He was wrong, but nevertheless, he has done a lot to make the name of mathematics rather tarnished in the world. Okay, so you're interested. What do you do? Well, the first thing you do is you have to think of your hardest problem, the hardest problem that you want solved, because the bottom line is probably someone in engineering maths can help you do it. Okay, you have to think really well, and you have to write it down in a simple one-paragraph statement, and you come and talk to us. Okay, and we might then set up some speed dating event or something. We'll have to sort out the details later on, and we're going to ask lots and lots of questions of you. Okay. There are ways that this can work, and this is not one of them, although it occasionally works, where you just don't get on. Your problem doesn't get on with us, and it's sorry, we just have to go, I'm terribly sorry, that's not the way it's meant to be. It does go that way, but as long as you have perception, as long as you understand what reality is like, the road to success is not going to be easy. It's going to be lots of bumps in the road. There's going to be lots of work to be done, and it's going to take a lot longer than you think. The way it really works is you bring along a problem. We then think about it. We ask you lots of questions. You then go back and think about it and ask us lots of questions. And we have this virtuous circle where basically theory and applications, if it all works, end up being very helpful to each other. It takes time. I know in this world of ref and deans and everybody demanding that you publish lots of papers, frankly, if you want to do something really good, you have to take time over it, and it involves lots of discussion, and you should get involved because it is like learning another language. I'm trying to learn Italian at the moment, and it's quite difficult. I have to learn electrical engineering, I'll have to learn computer science, I'll have to learn mechanical engineering, and similarly, you're going to have to learn the language of mathematics. But most of all, you have to say, I don't know things. This is the most important thing I find in these events, where you talk to one another and you put up your hand and you say, you know what, I actually don't understand what you just said there. And if that's the result to true understanding, he said. Second Nobel Prize winner in this talk. Success rate, well, it depends, but Thomas Watson said if you want to increase your success rate, you have to double your failure rate. I had very nice success recently with Alan Achim in electrical engineering. Small, but very perfectly formed. We're very pleased about it. But this whole way of going about it, of trying and failing and trying and failing, and trying and trying and trying until you succeed, is at the heart of this approach. And we just basically need lots more problems from people, and hopefully they can come along. There's a good example of another approach in August when machine learning is going to get eviscerated. Oh, sorry, that's my... with a conference about the mathematics of machine learning, which looks very interesting. But basically, all I would like you to do is to email me, and then we can start to get the ball rolling, and hopefully you will find out what engineering mathematics can actually do for you, rather than just listening to me. So I think I'll stop.